thumbnail. Well, good afternoon. So we'll start with the P block elements. We shall start with the P block elements. Now here, I have stopped that metallurgy topic since whatever the new syllabus has been declared. Under that full topic itself has been reduced. It is taken out. So for that reason itself, I am starting with the P block elements. Now, in this P block elements, last year, that is in the 11th class, you have learned regarding the 13 group and 14 group elements. The boron family and the carbon family elements you have learned. Now, this year, the 12th class, let us go further and let us understand regarding the whatever the 15th and the other group elements are there. So in this what we have, okay. So today we begin with actually the 15th group. Okay. 15 group elements are there. Now what are the 15 group elements? 15 group elements are nitrogen, phosphorus, arsenic, antimony and bismuth. Nitrogen, phosphorus, arsenic, antimony and bismuth are the 5 elements that which are present in the nitrogen family. Now these family elements, these are also called as nicogens. These are called as nicogens, and this word nicogens is being taken from the word nicomix. Nicomix means which are suffocation generating some kind of substance, like, okay. So all the nitrous oxides you take, nitrogen oxides or even the phosphorus oxides, they are going to be poisonous. They generate some kind of suffocation. They generate a kind of suffocation. So those set of compound, those set of elements, they are called as a nicogens, nicogenerating. So, and these compounds are also called as the nitrogen and the phosphorus, and the other compounds is called as nicomides. So nicogens is the family name, nicogens is the nitrogen family name. Then you have the nicomides, the compounds formed out of that, and this word, it has been derived from the word that is nicomix, which means it is suffocation. Suffocation generating mineral or compounds are there, gases are there. Further, now, so suffocation, that is you have to remember, it will create suffocation, right? The next is regarding the occurrence, where all it is occurring, okay? Occurrence. Occurrence in the metallurgy also, I was telling you, in the form of ore or mineral or something like that, it is available. So here, this also occurrence, nitrogen if you take, though it is 78% in the atmosphere if we say, then also in the Earth's crust it is very less. In the Earth's crust it is not in very large quantity. It is in a limited quantity. So nitrogen's abundance number is 33. How much of nitrogen is present in the Earth's crust? It is 33. Phosphorus, if you take, it is 11. Phosphorus, it is 11. So nitrogen in the atmosphere, it is present in the form of gas, but that we don't count in the Earth's crust. Earth's crust in the different form of minerals or something, it is different. Now why it is less? Why this nitrogen is less is, most of these nitrogen compounds what are available, they are available as nitrates. Okay, they are available as nitrates. Most of the compounds of nitrogen, they are available as nitrates, and nitrates are thoroughly dissolvable. Okay, thoroughly soluble they are. Thoroughly soluble in water. They are thoroughly soluble in water. Okay, and they shall be dissolving in the concentrated whatever the thing is there, so it shall be dissolving, and because of that, remember, nitrates which are available, they shall be soluble, and those compounds are not much available in the earth's crust. So those nitrates, important nitrates, if you take those nitrates, important nitrates, so those are some of them sodium nitrate. This is called as chili saltpeter. This is called as chili saltpeter. This chili saltpeter, it is available in the Chile area of the South America. Okay, large quantity it is available. Other parts of the world also it is available, but in a little less quantity. Then coming to the other one, potassium nitrate. Potassium nitrate, it is called as Indian saltpeter. Indian saltpeter. This is available in India in plenty. Okay, Indian saltpeter, it is available in the India in the plenty. Okay, further. So these are, nitrogen is available in the form of nitrates, but those nitrates are soluble in the water very thoroughly. Further, going to the importance of nitrogen. Where all we come across nitrogen in the day-to-day life. Nitrogen, it is okay in the proteins. It is there. Proteins, then amino acids, proteins, amino acids, nucleic acids, etc. Proteins, amino acids, nucleic acid, etc. In these, the nitrogen is present. So definitely from these words only you can make out how important is nitrogen in our daily life. So without proteins, can be imagined, not possible. For the body growth, the cell growth definitely require proteins, and proper functioning of the cells and the body, whole body itself, you require the amino acids. Nucleic acid, they are the part of the every cell there. So like this, nitrogen finds to be lot of importance in the day-to-day life. Further, these are available where? Okay, protein, amino acids, nucleic acids, these are existing where? They are existing in the plants also, they are existing in the animals also. They are existing in plants and animals both. Further, this nitrogen, it is going to be exchanged between the surroundings and the biosphere, the atmosphere. So it goes into the biosphere in one form, then goes to the atmosphere in some other form, some nitrogen oxides it might be going. Again, it is being absorbed by the different materials. Again, it goes back into the Earth's surface in different forms. So this whatever cycle is there of the nitrogen, so going to one form, then going to another form, then coming from the Earth's surface, all this, for that we call it as the nitrogen cycle. Okay, for that we call it as the nitrogen cycle. Then coming to the phosphorus. So phosphorus, already just now I told you, it is the 11th most abundant element. It is the 11th most abundant element in the Earth's crust. So in what form it is available? Again, it is available in the form of, it is existing in the form of orthophosphates. Mainly, it is existing in the form of orthophosphates. Okay, orthophosphates. Those orthophosphates and their family name, you can take it as hepatides. The family name of these orthophosphates is hepatides. So those hepatides are in what form? They are in the form of Ca3PO4 thrice. Ca3PO4 thrice is the PO4 twice. Okay, thrice. Ca3PO4 twice. Okay, so calcium phosphate, it is being existing. It is existing as calcium phosphate in many of the substances. In that, again, we have what are the different types of phosphorus that we have in the Earth's surface. So one will be phosphoroite, phosphoroite, phosphoroite. So Ca3PO4 twice this. Then, so this, okay, whatever these words are there, those are going to be present. Then fluorapatite is there. Fluorapatite. Fluorapatite. Fluorapatite, the formula will be Ca5, then PO4 twice, and yeah, Ca5PO4 twice, and yeah. Okay, phosphoroite, fluorapatite it is. PO4 thrice is going to be PO4 thrice, and yeah. Then similarly, fluorapatite if you take fluorapatite, fluorapatite, fluorapatite will be Ca5PO4 thrice, and C. If it's chlorine, then it is fluorapatite. If it is fluorine, it is fluorapatite. So fluorapatite, fluorapatite, in those forms it is available. The phosphorus is available or existing in these forms. Then where all these phosphorus minerals are existing? So one is in the North African region, another is North American region. Also in India, it is available in the Rajasthan region. Whatever phosphorus compounds are there, they are available in the Rajasthan area of our India. Further, coming to the importance of this. Now, the nitrogen we saw, it is useful in the protein, amino acid, nucleic acids, etc., etc., and they are existing in the plants and animals we discussed. Like that, if you go for phosphorus, now phosphorus is playing an important role in deciding the heredity. Okay, so in deciding the heredity, it controls the heredity effects in the animals, and that includes human beings also. It controls the heredity effects in the human beings. So what are heredity effects? Okay, like maybe the chromosomal activity it is controlling, and for that reason, because it is controlling the chromosomal activity, the different whatever hereditary type of related characters are there, those are going to be affected. Say for example, the eyes, or maybe the way of talk, or maybe the nose, or maybe some of the other psychological behavior, the way of handling different situations, all these maybe they are going to be affected because of the phosphorus. One can be phosphorus. Let's go for the properties now. Atomic and physical properties. Atomic properties, physical properties. Both. Let us see. Okay. Let us see. Atomic and physical properties. Atomic and physical properties. In this, first one is electronic configuration. Electronic configuration. Okay. In the electronic configuration, what is that? Okay. Let us take one or two examples, then we'll understand. We can easily remember that. Nitrogen, the number is 7. So 1s2, 2s2, 2p3. Then phosphorus you take. Phosphorus is 15. So 1s2, 2s2, 2p6, then 3s2, 3p3. So from these two itself, 2s2, 2p3, 3s2, 3p3. 2s2, 2p3 and 3s2, 3p3. What is our observation? Our observation is the general electronic configuration shall be ns2 np3. The general electronic configuration is ns2 np3. Okay, so this is first case or first whatever the property is there of the atoms that are belonging to the nitrogen family. The next one, atomic radius and ionic radius. Atomic radius and ionic radius. Okay, first of all, what is that atomic radius is? If you take the atom, let's say nitrogen atom, you take nitrogen atom itself. So the distance between the nucleus and the outermost electron, the distance between the nucleus and the outermost electron, for that we call it as the atomic radius. Then what is ionic radius? Ionic radius will be, now nitrogen, maybe it has taken up one electron. It has taken up one electron from the another atom. So that time also between the nucleus and the outermost whatever the new electron has entered, whatever that distance is there, so that will be the ionic radius. So atomic and ionic radius. Atomic radius, when it is an isolated atom, it is in the ground state, neither it has given the electron nor it has taken the electron. But when you take the ionic radius, either it must have taken up the electron or it must have donated the electron. Any one thing must have happened. So the distance between the nucleus and the outermost whatever electron is there, for that we'll call it as a ionic radius. Now here, okay, as we come down the group, nitrogen, phosphorus, and seven, whatever, arsenic, antimony, and bismuth. Okay, nitrogen, phosphorus, arsenic, antimony, bismuth. These 5 elements we are learning now. So as you come down the group, the atomic number increases. And since atomic number increases, the shell numbers, the electronic configuration when you are writing, so first is 2s2 2p3, next will be 3s2 3p3, its next will be 4s2 4p3, 5s2 5p3, then 6s2 6p3. Like that, the shell numbers are increasing, the electron is entering into the last shell, the new shell, the new shell, the new shell. Okay, so it is entering. And because electron is entering into that new shell, that's why the atomic size is large. And definitely, as you come down the group, because the electron is entering into the new subshell, so then what happens is, as you come down the group, there is going to be increase in the atomic size. So it is going to increase. It is going to increase down the group. Atomic radius and ionic radius if you take increases down the group. Okay, along the period we cannot discuss here. Along the period if you are discussing, you have to compare with the 14th group element and the 16th group element. 14th group element is carbon, then 15th group element is nitrogen, let's say, and 16th group element is oxygen. And as you come along the period, so what happens to the atomic radius is it is going on decreasing, because electron is entering into the same subshell. We say electron is entering into the same subshell, so atomic size goes on decreasing. So if you compare carbon and nitrogen, nitrogen is a smaller atom. Nitrogen is a smaller atom than carbon. Oxygen will be still smaller, the size I have written. Okay, nitrogen smaller atom than the carbon, and again, if you take oxygen, oxygen is going to be still smaller atom than the nitrogen. Why? Because electrons entering into the same subshell. Electron enters into the same subshell. Third, next property is ionization energy. Next property is ionization energy. Okay. So as you come down the group, atomic size is increasing. We have learned already. Atomic size increases means what will happen to the ionization energies? It should be decreasing because as the atomic size increases, little energy is supplied to that. Little energy is supplied to that, and it will release away the electron. Little energy is supplied to that, it will release away the electron. So there, as you come down the group, there is decrease in the ionization energy. Decrease, okay? Ionization energy decreases down the group. Because why? Okay, what is the reason for ionization energy increase? Atomic size is increasing. Whatever the screening or shielding effect may be existing, so that is also going to be increasing. Because of that, what will happen is there is a decrease in the ionization energy. So less energy is required as the atomic size increases. So the outer electrons will experience less force of attraction with the nucleus. The outer electrons experience less force of attraction of the nucleus. So little energy is supplied to the outer electrons. Little energy is supplied to the outer electrons and they shall be released quickly. So there is going to be decrease in the ionization energy down the group. Okay, so screening effect, shielding effect also are working there. So there is a little imperfection. General trend, if you take general trend, there is a decrease in the ionization energy down the group. Further, next property is electronegativity. Electronegativity. Now, what is electronegativity? Okay, the tendency of the atom to pull the shared pair of electrons towards itself. The tendency of the atom to pull the shared pair of electrons towards itself, that is electronegativity. Now here, as you come down, okay, that time I did discuss nitrogen, phosphorus, these two are non-metals. Arsenic, antimony, metalloids, or arsenic shows metalloid character, and antimony and bismuth, if you take, they are purely metals. Metals means what? Metals means those which are ready to donate 1 or 2 electrons. Those which are ready to donate 1 or 2 electrons, those become the metals. So electronegativity character, if you take down the group, as you come down the group from nitrogen to bismuth, the metallic character is increasing. The donation of electron, whatever nature is there, that is increasing. Because of that, what happens is there is going to be decrease in the electronegativity. There is going to be decrease in the electronegativity. So, like ionization energy, even electronegativity decreases down the group. Decreases down the group. Electronegativity decreases down the group. Here also, the reason is the same again. Atomic size is going on increasing. Atomic size increases, whatever the screening and shielding effect is there, that is also increasing, and that's why there is a decrease in the electronegativity nature. So, bismuth, if you take, it is a strong electropositive element. It's a metal almost. Okay, it's a metal there, and it will be giving away the electron more easily. It will give away the electron more easily. So electronegativity character is going to be decreasing there. Further, so now electronegativity decreases means metallic character, if you take, metallic character is increasing. Metallic nature or metallic character, as you come down the group, it is increases down the group. Metallic character of the 15th group element, it is increasing as you come down the group. The reason, okay, the reason is, so the electron donating capacity to the other atoms, it is increasing. As you come down the group, atomic size is increasing. Already we have discussed, atomic size is increasing. So when atomic size increases, ionization potential is less. Ionization energy is less. When ionization energy is less, little energy is supplied to the outermost electron, it shall release away the electron. Little energy is supplied to the outermost electron, it shall give away the electron so easily. So, it shall give away the electron means what? It is going to be metallic in nature. Okay, those elements, those atoms which are ready to give away the electron, for those we'll call them as the metallic. Okay, those which are receiving the electron, those may be non-metallic. Okay, coming to the next one. In this topic also they have reduced some content, so that is regarding the phosphorus and phosphorus halides and something, so that I shall not be taking up. So what is very important and what is there in the syllabus, that shall be taken up. So even they people, NCRT people, they have picked those topics which are very essential for life. Okay, the next property is regarding melting point and boiling point. Sixth one, melting point and boiling point. Melting point and boiling point. Okay. So for melting point there is one trend and for boiling point there is another. So there in the melting point what happens? Nitrogen to arsenic, when you come, it is increasing. Okay. So increases from nitrogen to arsenic. Then it is decreasing when you come from antimony to bismuth. Antimony and bismuth, there is a decrease. Okay. So now here we come across one effect called inert pair effect. Now when we have written the electronic configuration, say for example nitrogen, so it is 2s2 2p3 we say. So there are 5 electrons, 1 2 3 4 5. So in many examples what happens is the 5 electrons are involved, but out of those these 2 electrons, they are not involved in the bonding. Say for example NH3 you take. So in the NH3, 3 electrons of the nitrogen are involved in the bonding. 3 electrons of nitrogen are involved in the bonding and 2 are not involved in the bonding. Okay, so those 2, though they are present in the final shell, Those two, though they are present in the final shell, the valence shell, then too they are not involved in the bonding. They remain inert. Such a pair of electron which is remaining inert and which is giving the effect. That effect we call it as a inert pair effect. They are present in the valence shell, but they do not take part in the bonding. That effect we see in the first three elements, nitrogen to arsenic. Only three electrons are going to be involved. Further, when you come to the below elements, the antimony and bismuth, so there it forms only three covalent bonds. Nitrogen can form 5 bonds, but whatever this inert pair effect is there, it is there for all the 5 or all the elements down the group. But there what happens is, as you come down the group, the inert pair effect is less. The inert pair effect is less. So these two, antimony and bismuth, why it shows a decrease in the melting point is because of the three covalent bonds it is going to form. It forms only three covalent bonds. It does not form 5 covalent bonds. Okay, 3 covalent tendency is there to form only 3 covalent bonds instead of 5, and that tendency, this tendency to form only 3 covalent bonds is because of the inert pair effect. It is because of the inert pair effect. Because of inert pair effect, the nitrogen family elements from nitrogen to arsenic, if you take, it is showing the 5 electron bonds, 5 covalent bonds can be formed, but from antimony to bismuth, only 3 covalent bonds can be formed. So because of this, what happens is the attractive force between the nitrogen and the other whatever nitrogen atom may be there. So those are going to be stronger. As you come down, the melting point is increasing. So there, from nitrogen to arsenic, if you compare the bonding between nitrogen or phosphorus or arsenic, it goes on increasing. All the 5 electrons are involved in the bonding. But later, okay, from antimony to bismuth, though there are 5 electrons, all the 5 electrons are not involved in the bonding. Only 3 electrons in that. There's a little less attractive force between the antimony or bismuth elements, and that's why that's going to be having less melting point. Boiling point, if you take, boiling point is not going to be affected because of this. Boiling point, it is going to increase. Boiling point increases from nitrogen to bismuth. So there the attractive force, because already it would have melted. What is that boiling point is? Already the whatever the metal elements are there, they would be present in the melted position, so molten position. So there it is going to increase. There the electron, the 2 electron bond or the 2 electrons which are involved in the inert pair effect, they don't play important role. So whatever inert pair effect is there, we do not see in the boiling point whatever characteristic is there. In the melting point, definitely it is there, because 1 or 2 elements will be in the solid form also. Further, catenation property. Catenation. What is catenation property? Catenation property is a self-linking property. We see in the carbon, okay, we see in the 14 group elements, carbon can bond to the carbon, okay, self-linking of atoms. For that we call it as a catenation. So here also, for nitrogen family elements, all of them, they show the catenation property. Nitrogen can bond with the nitrogen. In the N2 H4, okay, hydrazine we say, P2H4, phosphine we say. So all those, there is going to be nitrogen double bond or phosphorus double bond, and even the further bonds are there. So there is some tendency, but which element will show the maximum catenation is? It is the phosphorus. Which element shows the maximum catenation is? It is phosphorus. Let me give you the bond energy value then. Okay. So depending on bond energy value, you can come to the idea. So here bond and bond energy. Carbon, carbon, nitrogen, nitrogen, phosphorus, phosphorus, arsenic, arsenic. Okay, these bonds. So here it is 353.3. Nitrogen, nitrogen it is 163.8. Phosphorus is 201.6. And arsenic if you take 147.4. So the bond between phosphorus, phosphorus, or carbon, carbon, whatever the bond energy is there, in terms of kilojoule per mole. In terms of kilojoule per mole. So after carbon in this set, if you take, we are seeing it for the phosphorus. For this reason, for this reason only, the phosphorus, it is going to show a strong nature of catenation, strong nature of catenation compared to the other ones, even the nitrogen, arsenic or any other. Compared to the others, phosphorus shows the maximum catenation in the nitrogen family. So that is regarding catenation. Then the next one is allotropy. And the catenation, I told you now just now. So catenation property is strongly observed in the case of phosphorus than other elements of the nitrogen family. Then the next point is regarding the allotropy. What is allotropy? Allotropy is same element existing in 2 or 3 different physical states. Chemical properties will be same. For allotropic substances, chemical properties are same, but physical properties will differ. Now, in the carbon family elements, you have learned diamond, graphite, etc. There, the diamond and graphite, the physical whatever arrangement is there, that is different. The physical arrangement is different. The chemical arrangement is same, or the chemical behavior, what we say, is same. Graphite you burn or diamond you burn, it shall give you carbon dioxide. So chemical properties in there. Physically, if you take diamond, it has a refractive index, high refractive index. But graphite, if you take, it has very low refractive index. Okay, so like that, allotropy means those elements which are existing in 2 or 3 different physical forms, wherein they are having different physical property, but the chemical property is going to be the same. Now here in the nitrogen family elements, nitrogen does not show the allotropy. But when you come to phosphorus, okay, nitrogen and these two are not showing the allotropy. It's an exception. They do not show allotropy. But if you take phosphorus, you have white phosphorus, you have red phosphorus, you have black phosphorus. Okay, so you have white, red, and black. 3 kinds of phosphorus are present. Further, arsenic, if you take, arsenic is present in the yellow form and grey form. Yellow and grey form. 2 forms of arsenic are present. Then antimony, if you take, Antimony, it is going to be yellow, silvery gray. Yellow, okay, and silvery gray. These are the forms of the antimony that which is present. Further, one more thing regarding oxidation state we shall see, and we'll wind up for today. Okay, so these are the 8 different atomic properties I can say. Now let us go to the other way, one more atomic property only, that is oxidation states. Oxidation state. Okay. Now in this oxidation state can exist for these nitrogen family elements from -3 to +5. They can accept 3 electrons, they can give up to 5 electrons. So it starts from -3, -2, -1, 0, then 1, 2, 3, 4, 5. Like this, total 8 to 9 different oxidation states it can be existing. So for one example, that is for the nitrogen, you can take NS3, N2H4, hydrazine they say. Then you have NH2OH, hydroxyamine, further N2, then N2O, then you have NO, N2O3, N2O4, then N2O5. Okay, so what are the different oxidation states? In the NS3 it is -3. Oxidation state if you take, so for NS3 it is -3. So here it is -2 because hydrogen will be +1. So there are 3 hydrogens, so +3. So our nitrogen should be -3. Hydrogen here is +1, so there are 4 hydrogens. 4 hydrogens being balanced by 2 nitrogens, so each nitrogen -2. Then here it is -1. This is 0. Then we have here oxygen will be -2. Oxygen is -2, so each nitrogen should be +1. Here oxygen is -2, so nitrogen should be +2. Then here oxygen, total oxygen -6, so each oxygen +3. Then each oxygen -2, 8, total will be 8. 4 2s are 8. So 8 should be divided by 2 atoms of nitrogen. So each one will be +4. Then N2O5, each oxygen -2. So 5 2s are 10. -10 is divided among 2 nitrogen, so it will be +5. So what is our observation? Nitrogen can exist in -3 to +5, these many different oxidation states. This is one example for the oxidation state. Like this, the phosphorus and other elements also will be existing. But moving down the group, what happens is the stability of +5 oxidation state decreases while that of +3 increases. So down the group, what happens? Down the group, +5 oxidation state decreases. +5 oxidation state decreases. Okay, and +3 oxidation state increases. The stability. What is decreasing here is the stability of that. It will form compound, but is it going to be stable? No. Okay, +5 oxidation state compounds are going to be less stable. But +3 oxidation state compounds if you take, +3 oxidation state compounds if you take, it is increasing. So +3 containing whatever molecules are there out of these nitrogen family elements. So there that stability is increasing. Now what is the reason for this? Why plus 3 is increasing? Because of inert pair effect. What is the inert pair effect is? The tendency of the two electrons of the s level, the tendency of the two electrons of the s level to remain as inert. The tendency of s electrons, two electrons of the s level to remain as it is inert, that we call it as the inert pair effect. They do not get involved. They are inside, very much inside. Inner core electrons, like that we can call. So since they are very much inside, they do not take part in the bonding. So they, because of that, what happens? Only the three electrons of the outer shell are going to be involved in the bonding. So oxidation state, that is plus 3, its stability, the compounds formed out of that stability is more, and the stability of plus 5 oxidation state is less. Now this topic, I tell you one more thing, this topic is a very vast topic, okay, very vast topic in the whole of this 12th standard. So we shall definitely go with, but at the same time remember, enormous number of questions can be appearing for it, n number of questions. So we cannot tell you here this question only. It can be asked like maybe in the haloalkanes, haloarenes and other topics, there is a chance SN1, SN2 and like that. But here it's a very vast topic. So little bit telling you that questions can be asked on this only, it's little difficult. Inert pair effect is definitely one such area where question can be asked related to this. Oxidation status, another area where question can be asked. Okay, so with this, today's class I just wind up, and in the next class, tomorrow's class, we shall go further. Okay, we shall go further on this. Thank you.